Welcome to Galactic Secrets, your portal to the most mind-bending theories and discoveries in the universe. In today's episode, we're exploring a topic that bends the very fabric of reality itself, time dilation and its implications for long-distance space travel. Have you ever wondered what it would be like to travel to the farthest reaches of the universe and return to a world where everyone you knew has aged or passed away? How can time move differently for space travelers, and what does that mean for the future of space exploration? We've got all the answers. Before we dive in, remember to subscribe, hit that notification bell, and don't forget to share this video with your friends and family so you never miss an episode. Part 1. Time dilation. Einstein's relativity explained time dilation is one of the most mind-bending concepts in Albert Einstein's theory of relativity. According to his theory, time is relative. It moves differently depending on how fast you're going. For example, as an object approaches the speed of light, time starts to slow down for the people or objects moving at that speed. This means that astronauts traveling at near light speeds would experience time much more slowly compared to people on Earth. A journey of just a few years could mean that, upon returning, they find Earth has aged by centuries. This is not science fiction but science fact. The theory has been proven in many experiments, including tests using atomic clocks in fast-moving jets and satellites. Part 2. Time dilation and long-distance space travel. Now let's take this concept to space travel. The universe is incredibly vast, and even the nearest star, Proxima Centauri, is 4.24 light-years away. While it might seem impossible to travel these distances in a human lifetime, time dilation could be the key to making it feasible. If astronauts were able to travel at a significant fraction of the speed of light, the journey might only take a few years from their perspective, while many decades or centuries pass on Earth. This creates a fascinating paradox. The astronauts would age more slowly than everyone else on Earth. They would return to a future world, one vastly different from the one they left behind. Imagine leaving Earth for what feels like 5 years and returning to see 200 years of human progress. This scenario could become a reality if we unlock the ability to travel at relativistic speeds. Part 3. Real-life examples of time dilation. GPS satellites. You don't need to go to outer space to see time dilation in action. It's happening every day, all around us. One of the best real-world examples is GPS satellites. These satellites orbit Earth at high speeds and experience weaker gravitational forces than we do on the ground. Because of this, their onboard clocks tick slightly faster than clocks on Earth. The time difference is small but measurable, and it needs to be corrected for GPS systems to provide accurate location data. This is a form of gravitational time dilation. Time slows down in stronger gravitational fields. Imagine what happens when you scale this effect up for objects moving at near light speeds across the galaxy. Part 4. Black holes and extreme time dilation. Let's go a step further and talk about black holes, one of the most extreme environments in the universe where time dilation reaches its peak. Black holes have such strong gravitational pulls that time near them slows down dramatically. This phenomenon is called gravitational time dilation. An astronaut orbiting near the event horizon, the point of no return for a black hole, could experience minutes passing while years or centuries fly by for people far away from the black hole. Although getting too close to a black hole would likely result in being crushed by gravity, in theory, they are the ultimate natural time machines. Science fiction often portrays black holes as portals to other times or dimensions, and while these ideas are speculative, they are based on real physics. Part 5. The speed of light. The ultimate cosmic speed limit. The speed of light, 299,792,458 meters per second, is the fastest speed at which any information or matter can travel. As objects approach this speed, time dilation becomes increasingly pronounced. In fact, at the speed of light, time would theoretically stop altogether. While we cannot reach or exceed the speed of light with current technology, understanding time dilation helps us imagine the possibilities of future space travel. Breaking the light speed barrier remains a challenge. According to Einstein's theory, the closer we get to the speed of light, the more energy is required to accelerate further. Essentially, it would take an infinite amount of energy to reach the speed of light, but what if there were ways around this limitation? Part 6. The challenges of communication. Relativistic delays. One often overlooked challenge of long-distance space travel is communication. As astronauts travel at near light speeds and experience time dilation, communication between them and Earth becomes problematic. If they're experiencing time more slowly, their messages will reach Earth far in the future, causing massive delays in conversations or mission updates. This leads to new challenges for coordination between space explorers and those left behind on Earth. Could artificial intelligence be the solution, helping to manage these communications and allow real-time decision-making, even across vast distances? Part 7. Could cryosleep or wormholes solve the time dilation problem? In many science fiction stories, long-distance space travel is solved by placing astronauts into cryosleep or suspended animation. This idea would allow astronauts to sleep through the long journey while their bodies remain young and fresh for their arrival at a distant planet. Although we're far from achieving cryosleep technology in real life, time dilation offers a similar possibility, compressing the duration of interstellar journeys, at least from the perspective of the travelers. Another theoretical possibility is wormholes, shortcuts through space-time that could allow us to travel vast distances in a fraction of the time. Wormholes, if they exist, could bypass the need for time dilation by providing faster-than-light travel between 2 points in the universe. Though purely speculative, these ideas spark the imagination and offer hope for overcoming the limitations of time dilation and the speed of light. Part 8. The psychological and social impact of time dilation on astronauts. Imagine being an astronaut traveling through space at near light speeds. Not only would you face the challenges of space travel itself, but the psychological impact of time dilation could be profound. The knowledge that time is moving faster for everyone else, your family, friends, and the entire human race, could be deeply disorienting and isolating. How would astronauts cope with the idea that they might return to a future Earth where everyone they knew has aged or died? This psychological toll could become a major factor in planning future space missions. Long-distance space travel, combined with time dilation, presents not just technical challenges but emotional and existential ones as well. Part 9. The future of space travel, harnessing time dilation. As we look toward the future, time dilation may be more than just an interesting consequence of relativity. It could become an essential tool for humanity's expansion into space. Scientists and engineers are exploring advanced propulsion technologies, like nuclear fusion or antimatter drives, that could theoretically bring us closer to light-speed travel. While we aren't there yet, the next few decades could see breakthroughs that allow us to use the effects of time dilation to explore distant star systems, colonize exoplanets, and perhaps even interact with other intelligent civilizations in the universe. Could time dilation hold the key to making humanity an interstellar species? Or will we find other ways to leap across the stars? The future holds exciting possibilities, and we are just at the beginning of this cosmic journey. Conclusion. So, what do you think? Could time dilation be the key to interstellar exploration? Let us know in the comments below. Make sure to subscribe, hit the notification bell, and share this video with your friends and family to never miss an episode of Galactic Secrets. Stay tuned for more fascinating insights into the mysteries of the universe.